The last week we did was the distance time graph. Today we'll do the velocity time graph. The velocity time graph, remember, using a velocity time graph, you can find two things. Number one, you can find the acceleration, which is the acceleration or deceleration, which is a slope. Number two, you can find a distance or a displacement. Both can be calculated from a velocity time graph, and how we calculate by using the area. But to get the distance and displacement, a small difference is there. The first one, you should understand the shape of the graph and then how we can use to calculate certain values. So example, we have a velocity time graph, which is on y-axis, we have a velocity, meters per second, and on x-axis, we have a time. We may have a velocity time graph, a horizontal line above the origin, a horizontal line on x-axis, or we may have a horizontal line below the origin. This shows it's a positive velocity. This shows it's a negative velocity. This shows that the velocity is 0. What about the how they are all different from each other? The first one, like example, if I say A, B, and C, the first one, A, means that the object is moving at a constant velocity. If a right-hand side I consider as positive, so maybe this object is moving at a constant velocity of 3 meters per second towards the right. That is A. What about B? B means the object is not moving, it is stationary because the velocity is 0. What about C? C shows it is moving, but in opposite direction of the original. So if this was a +3 example, this is -3. So it is moving in opposite direction. All of them are representing, like the A is representing a constant velocity. B is also representing a constant velocity. B is representing 0 velocity and C is representing constant velocity. What is the difference between positive and negative velocity? It only shows the directions are opposite. And all these examples, what about the acceleration? The acceleration is 0 here, acceleration is 0 here, and acceleration is 0. Because horizontal line, the gradient or the slope of a horizontal line is always 0. That's the first case. We may have a graph, a velocity time graph for an object which is having a straight line. It is same like a displacement time graph. The last week we did the displacement time graphs, that when there's a displacement time graph, the slope represents the velocity. Here, when we have a velocity time graph, the slope represents the acceleration. So if we have a velocity time graph, straight lines, what we can say about the velocity of this object, it is increasing. But what about the slope, acceleration? Because the slope represents the acceleration. What is the acceleration of this object? It's a straight line. What is the slope? Yeah, straight line, the slope is always constant. So acceleration is constant here. But what about the value of the acceleration? Is it a positive acceleration or a negative acceleration?
Positive.
So positive acceleration. Because how you identify it's a positive acceleration? Positive acceleration means like when you work out, the value of a y2 is above y1, so it is a positive acceleration. What is the meaning of the term positive acceleration? The term positive acceleration only means that the direction of the acceleration is same as the direction of the motion. If we get a negative acceleration, what does negative acceleration mean? The negative acceleration means the direction of the acceleration is opposite to the direction of motion. So this is a constant acceleration which is positive. We can have a straight line graph like this. What is the acceleration of this object? Constant, increasing, decreasing. What is the acceleration of this
Constant.
object? Because again, it is a straight line, so straight line acceleration is constant. What about the value of the acceleration?
Negative.
Negative. Because how to work out negative or positive? When you draw a line from x-axis, if you find y1 is above y2. So if the y1 is above y2 means it will be negative. So this is a negative acceleration. What about the third one? If we have a graph like this, what is the expression of this object?
Constant,
So constant and
negative.
constant and negative. Because when you work out the value of y1 from the x-axis and the y2, the y1 is above y2, that's why it is negative. And it is a constant as well. Constant means that acceleration is not changing. Or the change in the speed is same. Every second, the same amount of the speed changes. So whenever acceleration is negative, as I mentioned, we also call that as a deceleration. So you can also say it's a deceleration or a negative acceleration. What about the last one? The velocity time graph. It has a constant. A is constant because it's a straight line. The slope is constant. But what about the value? So when you draw the line, the y1 and the y2, so y2 is above y1, so it is positive. So it is constant positive. So these are the four possible graphs for the constant acceleration. The value of acceleration can be positive or negative depending on the position of the y1 and y2. But these are all the constant acceleration graphs. Is it clear, the first part? Any doubt or
Yes,
a
sir.
question?
No.
Yes, Taha, Shahir, Muhammad Shayan, Mubashir, Muhammad Isa, Ammar, Mirza Ammar. Any doubt in this? Okay. The next is a velocity time graph. As we are doing a velocity time graph, we may have an increasing so if we have a velocity time graph, the velocity is there on y-axis and time is there. What we can say about the slope of this graph? Slope of this graph.
Increasing,
So slope is increasing, so means acceleration will increase. And what about the acceleration, positive or negative? What
positive.
about, so it will be positive. If I draw another graph, a similar graph like this, like a mirror image of this one, I'm just using the same axis, explaining the graph, but it's a different graph. What about the acceleration of this object?
Decreasing,
Increasing.
Increasing. Why it is increasing? Because if you work out the angles here, if you work out the angle with the x-axis, like angle here, the first angle, and when you draw a line and angle here, these two angles are different. Angles is increasing. So if angle is increasing, it means the acceleration is also increasing. But what about the value of the acceleration?
negative.
So the value will be negative. So it is an increasing acceleration, but a negative value. Is it clear?
Yes.
If we have a velocity time graph, if we have a velocity time graph and it is like this, what we can say about the acceleration? What we can say about the acceleration? Increasing or decreasing? It is important to understand the slopes.
Increasing?
Increasing. How it is increasing? Because when you draw a horizontal line, here, the first angle, when you measure the first angle, and you draw the horizontal line at this point, you will find that the angle with the horizontal line has increased. So if the angle with the horizontal line has increased, it means that acceleration or the slope has increased. So this acceleration is increasing. But what about the value of the acceleration? Is it positive or negative?
Negative.
Negative. And you can see the graph which I drew here, actually it's the same thing I draw again. So this is actually the same graph, but the difference was that this was below the y-axis, this is above the y-axis. But the shape remained the same. As the shape remained the same, it means the trend remains the same. So this was acceleration increasing negative. This is also acceleration increasing negative. Yes, Hafsa?
Sir, the two graphs that are same, but in the different positive and negative. So the velocity is negative in one and positive in the other?
Yes. Because what velocity is showing, it shows that the direction of the motion. Like when it's in a positive axis, maybe the object is moving towards the right. When it is a negative axis, it's moving toward left. So velocity shows the direction of the motion. But that has the same change when it is moving towards right or the left. The acceleration was increasing and it was in negative direction, like deceleration.
Okay.
What about this one? What happened to the acceleration here? Acceleration is a slope. Draw the x-axis with then the second one. So what happened to the acceleration is increased. And what about the value of the acceleration? Positive.
Positive.
How we identify it's positive? Because y1 and y2, so y2 is above y1, so it will be positive. Same way, we may have a decreasing acceleration graphs, like this is one. If you have a velocity time graph, so this is decreasing acceleration. As you can see, the slope is decreasing, so the acceleration is decreasing. What about the value of this acceleration?
Negative.
So it is negative.
Oh.
Same, because when we draw the line from the first y1 and y2, so y1 is above y2, so it will be negative. What about this one?
Decrease.
So it is decreasing and it will be positive, because when you draw y1 and y2, so you will find y2 is above y1. That is why it is positive. And if we have a graph like this, what about the acceleration here?
Decrease.
And
positive.
Positive. What about the acceleration here? If you see the same I drew, this was same as this graph. So, and this is identical to this one. So acceleration is decreasing, but it is negative. So these are the possible graphs for the velocity time graph. Yes?
Sir, in the last one, how is it decrease and positive or negative?
How it is decreasing? Because when you take the angle with the x-axis, like this is the first angle with x-axis, but when we draw an x-axis here, the angle decreases. It's the same one as this one.
Okay.
And then what about the value? How to work out the value? So this is the first quantity on y-axis, y1, and the second is y2. So y1 is above y2. Because the y1 is above y2, it means it should be negative. So these are the possible shapes. These are the possible shapes of the velocity time graph. Now, what we can calculate an acceleration, or we can calculate the displacement. Third one graph, can you show the angles? For the third graph, if I measure the angle, so this is the first angle, this will be the second angle. So angle is decreasing, it means this acceleration is decreasing. When I measure the angle, this is the angle, the first angle, and this is the second angle. So angle is decreasing. It means the acceleration is also decreasing. Acceleration for straight, no, whenever we calculate acceleration is always calculated for a specific point. So if we want to calculate the acceleration, so we have to find the gradient. The term positive and decreasing, what does it mean? Like example, the value of the acceleration will be positive, but its value will decrease. Like example, acceleration was 3 meters per second square, then acceleration will be 2 meters per second square. So what does it mean? It means the acceleration is decreasing and the value or the magnitude is positive. Now, say this is a velocity time graph. We'll just use it to answer the question. Like, say, what if you have a question in exam, then sketch an acceleration time graph of this one, okay? So first thing you have to divide this into parts, the segments, because the whole graph is not identical. So from A to B, what happened? A to B, what will happen? A to B, what happened to acceleration? Yes, good, Imad. A to B, the acceleration is decreasing. And what about the value of the acceleration?
Positive.
Positive. Then from B to C, what will happen? Moving from B to C. So from B to C, acceleration is decreasing or it is increasing? So when we take the angle, the acceleration is increasing. And what about the value? The value will be negative. Then moving from C to D, what happened to acceleration?
Decrease.
The acceleration is decreasing. So from C to D, what happened to the acceleration? The acceleration decreases. And what about the value of the acceleration?
Negative.
Negative. And from D to E, what happened to the acceleration? So acceleration is increasing. And what about the value?
Positive.
Positive. Now, if I say sketch a graph for this acceleration time graph for this motion. So we will take acceleration because acceleration is a vector quantity. So we have to use both axes. So this is a positive acceleration, this is a negative acceleration, and here's the time axis. From A to B, acceleration should decrease and it should have a positive value. So now the value of the acceleration should decrease. So say this has a maximum value, then the acceleration should decrease and it should have a positive axis. So acceleration will decrease and the positive axis. Is it clear? From A to B when I draw?
Here,
yes.
Here there isn't y1, y2.
Which one?
Like the acceleration one.
No need, because using the slope of acceleration time graph, you don't get any physical quantity. You don't find any physical quantity. That's why you don't need to bother about y1 and y2. Here, when you want to check, because see, velocity time graph, the slope represents the acceleration. And acceleration is on the y-axis. So these are the values of the y-axis. This is all the values of the y-axis. So first, what will happen? The value of the y-axis is positive and it is decreasing. So how the value of the y-axis is positive and decreasing? So the shape of the graph will be like this. Then from B to C, the value of the y-axis is negative and increasing. So how I will draw that it is negative and increasing? So from B to C, it is going negative and it is increasing. So this is from B to C. Is it clear?
Yes.
Then from C to D, the value of the y-axis is decreasing but negative. So decreasing but negative. So from C to D, the y-axis value should decrease. The y-axis value should decrease and negative. So this will be the value of the y-axis decreasing and negative. And from D to E, the value of the y-axis is positive and increasing. So from D to E, the value of the y-axis is positive and increasing. So this will be the acceleration time graph for the motion of this object. Is it clear? How I worked out the...
Does it have... Does it have to be like the left side line should be perfect to the right hand side line?
No, this is just a sketch. This is a sketch is there.
Like
that's why
C should be in the middle and...
Yeah. In that, because what will happen, the velocity time graph, the area under the graph will give us the displacement. So when this is a positive displacement, like object moved towards right and then it returned back. So when it is making this, the total distance should be same. The length should be same. But this is just a sketch. I will do the questions with the values as well. But to give you an idea that whenever we have a velocity time graph, we can work out the displacement time graph or acceleration time graph. So if we have a velocity time graph, if we want to work out the acceleration time graph, so what we have to do, we have to check the slope. Is it clear, this example? Any doubt in this?
Yes.
Any question or a doubt? How can you do a displacement time graph as well? Yes, I will. That's the topic of today. Like today's topic is how we can use different graphs, velocity time graph or acceleration time graphs to work out. So I'll share another link and join from that link. Because today is important topic like how to relate displacement time graph with velocity and velocity time graph with acceleration. So I'll share another link, join from the link. So we'll continue this topic.